For decades, Pluto was seen as little more than a frozen relic at the edge of the solar system, an icy world of rock and nitrogen ice, far removed from the dynamic activity of the larger planets. However, thanks to the incredible advancements of the James Webb Space Telescope, JWST, our understanding of Pluto has undergone a dramatic transformation. The latest images and data from JWST reveal a world far more complex than previously thought, challenging our assumptions about planetary geology, habitability, and the fundamental nature of celestial bodies in the outer solar system. From the possibility of a vast subsurface ocean to ongoing geological activity and the presence of complex organic molecules, Pluto is proving to be anything but a lifeless rock. These discoveries are forcing scientists to rethink what it means to be a habitable world and raising the tantalizing possibility that Pluto could even support some form of life. One of the most astonishing revelations from JWST's observations is the extent of geological activity occurring on Pluto's surface. Despite its vast distance from the Sun, Pluto exhibits signs of movement and change that defy previous expectations. Towering ice mountains, deep canyons, and smooth plains indicate that Pluto's surface is constantly reshaping itself. The dwarf planet was once thought to be geologically dead, frozen in time due to a lack of internal heat. However, new evidence suggests that Pluto is anything but static. At the heart of Pluto's geological transformation is Sputnik Planitia, the famous heart-shaped region on its surface. Originally believed to be just a massive expanse of frozen nitrogen, this area now appears to conceal an enormous subsurface ocean beneath a thick ice shell. If confirmed, this discovery would place Pluto in the same category as Jupiter's moon Europa and Saturn's Enceladus, both of which are prime candidates in the search for extraterrestrial life. This underground ocean, likely kept liquid by the slow decay of radioactive elements in Pluto's core, could remain in a stable state for billions of years. The possibility of liquid water existing on a body as distant as Pluto is a game-changer, as it suggests that habitable environments could exist far beyond the traditional Goldilocks zone around a star. Could microbial life have found a way to survive within Pluto's hidden waters? The very idea is forcing scientists to reconsider how and where life might exist in the cosmos. A major puzzle surrounding Pluto is its ability to sustain geological activity despite its frigid temperatures. Traditionally, planetary scientists believed that only large planets with strong internal heat sources could exhibit dynamic geological processes. Yet Pluto, a small, icy world on the outskirts of the solar system, is defying these expectations. One explanation lies in convection within Pluto's thick nitrogen ice. As heat from the interior rises, it creates a slow-moving cycle similar to a lava lamp, reshaping the surface over time. This process explains why parts of Pluto's landscape appear relatively smooth compared to older, heavily cratered regions. In contrast to the barren landscapes of other small celestial bodies like the Moon or Mercury, Pluto's surface appears to be constantly renewed. This phenomenon suggests that Pluto remains geologically active, something once thought impossible for an object of its size. Another source of heat could be gravitational interactions with its largest moon, Charon. Unlike most moons, Charon is nearly half the size of Pluto itself, causing the two to orbit a shared center of gravity located outside Pluto's surface. This unusual dance generates tidal forces, which could produce internal friction and heat, enough, perhaps, to sustain the activity beneath Pluto's icy shell. Pluto's largest moon, Charon, is just as mysterious as the dwarf planet itself. Its surface is marked by deep canyons, towering cliffs, and vast regions of unusual reddish-brown coloration. The exact cause of this reddish hue remains a topic of debate, but scientists suspect it could be due to the presence of tholins, complex organic molecules formed when ultraviolet radiation interacts with methane. Intriguingly, there is evidence to suggest that material is being exchanged between Pluto and Charon. This raises the possibility that organic molecules, essential for life, could be transferred between the two bodies, undergoing further chemical reactions over time. The idea that celestial bodies can share materials in this way introduces a fascinating new perspective on how the building blocks of life might spread across the solar system. Could Pluto and Charon be engaged in a slow-motion exchange of organic material, creating a miniature ecosystem in the outer solar system? If so, this could provide crucial insights into how life might originate and evolve in extreme environments. Despite its small size, Pluto possesses a surprisingly complex atmosphere. Composed primarily of nitrogen, with traces of methane and carbon monoxide, Pluto's atmosphere is highly dynamic, expanding and contracting depending on its distance from the Sun. As Pluto moves along its elongated orbit, its atmosphere sublimates, turns directly from solid ice into gas, when the planet is closer to the Sun, then refreezes onto the surface as Pluto moves farther away. This unique cycle has no parallel elsewhere in the solar system. The JWST has also detected haze layers extending hundreds of miles above Pluto's surface, suggesting that complex chemical interactions are occurring at high altitudes. These atmospheric processes contribute to the formation of tholins, the organic compounds that give parts of Pluto and Charon their reddish coloration. Since tholins are thought to play a role in the chemical evolution of life, their presence on Pluto hints at the possibility of prebiotic chemistry occurring on its surface or within its hidden ocean. If Pluto truly harbors a subsurface ocean, the implications for the search for extraterrestrial life are profound. On Earth, deep-sea hydrothermal vents host thriving ecosystems, powered not by sunlight but by the heat and chemicals released from the planet's interior. Could similar environments exist beneath Pluto's ice? If microbial life can survive in Earth's deep, dark oceans, it's not impossible that some form of extremophile organisms could exist within Pluto's hidden waters. The discovery of life on Pluto, no matter how simple, would revolutionize our understanding of the universe. It would prove that life is not confined to the inner solar system, and that even the most extreme environments can harbor living organisms. This would dramatically increase the likelihood that life exists elsewhere in the cosmos. The revelations from the James Webb Space Telescope are just the beginning. While JWST has provided extraordinary insights, a dedicated Pluto mission is needed to confirm many of these discoveries. Scientists are currently considering proposals for orbiters, landers, and even robotic submarines that could explore Pluto's potential ocean. A robotic probe equipped with ground-penetrating radar could map the extent of Pluto's subsurface ocean. A lander could analyze its surface chemistry in greater detail. In the distant future, a nuclear-powered submarine could one day dive beneath Pluto's ice, searching for signs of life in its hidden waters. While these missions remain in the conceptual stage, advancing technologies are bringing them closer to reality. If and when we send a dedicated mission to Pluto, we may finally unlock the secrets of this enigmatic world. Pluto, once dismissed as a minor celestial body, is now at the forefront of planetary science. Thanks to JWST, we now know that Pluto is an active, evolving world, possibly harboring an ocean, complex organic chemistry, and conditions that could support life. These discoveries are rewriting our understanding of the outer solar system and raising profound questions about the nature of habitability in the universe. Could Pluto be home to life? What other surprises might be waiting beneath its icy shell? One thing is certain, the story of Pluto is far from over. With every new discovery, we are reminded that the universe is far more mysterious, dynamic, and full of potential than we ever imagined.